All right, in this lesson, we're going to analyze graphs of functions. All right, so these are words that you maybe remember from Algebra 1, the domain and range. The domain on a graph represents all the values from left to right, and the range represents all the values from bottom to top, right? In that exact order, right? The domain always goes from left to right. The range always goes from bottom to top. The only thing new about this versus what you did in Algebra 1 is that you need to write your answers in interval notation, all right? If you see a solid dot, or what you guys know as a closed circle, right, that represents a bracket, and if you see an open dot or an open circle, right, that represents parentheses, all right? The other thing that might be new but shouldn't be too difficult is our intervals of increasing, decreasing, and constant, right? You always read the graph from left to right, and if it's increasing, that means it's going up from left to right, so it might look something like that. It could curve also, it could curve that way as well, all right? Or it could go like maybe like a little squiggle, right? But no matter what, it should be going up from left to right. Decreasing, right? You can probably guess is going to go down from left to right, right? So it might look like any of these, right? Any of these sort of scenarios right here. Constant is going to look one way and one way only, and it's going to be straight from left to right. It's going to be completely horizontal. And again, you're going to write your answers in interval notation. Open dots, always, right? So you're always going to use parentheses, no except for the sake of this lesson, right? There's, depending on who you ask, you might have brackets over constant values, but for the sake of this lesson, I'm just going to have open dots or parentheses everywhere in interval notation. All right, so let's find the domain and range and any increasing, decreasing, or constant behavior. All right, so let's start with this first one. Let's find the domain and the range. All right, so the domain and range represents from left to right, bottom to top, right? So with the domain, you're going to start from the left and you're going to go all the way right. So I'm going in this direction, right? I'll do it in blue, right? So I'm going in that direction from left to right. And we keep going in this direction. And where is the first value of x that you hit? Hopefully you guys can see it's at this open circle right here. All right, so I'm going to make a little line, or just to denote that that's our first value from left to right that we touch, right? And that's at -3. So that means my domain is going to start at an x value of -3, comma, and then I'm going to keep going. Where does this little bit end, right? I'm keep going up from left to right. I'm still touching the function, but I stop touching the function at this point right here. Again, the domain is always from left to right, and we're always looking at our x values. And this looks like it's an x value of 0. And there is a closed circle there, so it's going to be 0 with a bracket. All right? Now I'm going to keep going from left to right, and it looks like there's a little gap right here, right? Hopefully you guys can see this little gap doesn't have any of our function in it, right? So I'm going to need a little union to represent that I'm going to have another interval, right? Because you guys can see if you keep going from left to right, we do end up touching our function right here at an x value of 2, right? We keep going from left to right, and then that's where we start touching it again, right? So I'm going to draw a little line connecting it to the x-axis. We're going to have an x value at 2 with an open circle, so it's going to be parentheses 2, comma, and then this is going to keep going forever and ever, right? We have an arrow. It looks like it's pointing up, but that doesn't mean it's going to end, right? If it's pointing up, that just means it's kind of going, even though it might not look like it, you can pick a really large x value and you're still going to have a point on our graph, right? So it's really going forever and ever to the right, which means this is going to stop at infinity, all right? And so that is our domain, all right? We can do the exact same thing with our range. I'm going to go this time from bottom to top, all right? So going from bottom to top, it looks like the first point in which we touch our graph starts right here, right? And it looks like it's that value of 0, right? So this is a y value of 0, right? Let me connect that to the y-axis, right? 0, and it's an open circle, so I'm going to have a parentheses around it, comma, and then I'm going to keep going up, right? And then from here, when I keep going up, I stop touching the graph again, at this closed circle right here, but I'm looking at the y value, which is at 2, right? So it's going to go from 0 to 2 with a bracket, right? And then I need another union because I have another little gap right here, right? And then I start touching again at this open circle right here. Now look at the graph. That's a y value of 3 with an open circle. So it's going to be 3 comma, and then we're going up forever and ever. So up forever and ever we denote as infinity. So that is the range of our function, right? Some of you might have been able to do that super quickly, right? But then some people need to analyze it a little bit harder, right? We're all at different levels of it, so if you can do it right away, great, but otherwise that's how you need to think about it, right? You're going from left to right, and you're going to see where are you on your graph, where are you off your graph, right? And that's in general how you would do that, all right? Let me actually find the domain and range for the rest of these before I do increasing, decreasing constant, all right? So let's do domain again and range. Now again, from left to right, I'm going to go all the way to the left. It looks like the first part in which we touch looks like it's at this little arrow, but again, an arrow means that it's never going to end, right? So even though it's pointing downwards, we can't assume that it's ever going to end, so we're actually going to start from left to right at negative infinity, all right? And then when we keep going this way, right, so if I keep going that way, it looks like we stop touching our graph right here at negative 2. So it's going to be negative 2 with a parentheses, all right, because of that open circle. And then I have this gap, right? We're still going from left to right. I have a gap. It looks like we start touching the graph again at this closed circle at 1, right? So I'm going to have a union with a bracket at 1, comma, and then we're going to keep going. It looks like we keep going and we stop touching our graph at this open circle right here, which is an open circle at 2. So parentheses at 2. All right, so then that's our last little value. All right, so this represents, right, this little interval right here represents all of our values from left to right. So this captures all of the possible values in our graph. And we can do the exact same thing with the range. Again, going from the bottom to the top, use a different color, right? Going from the bottom to the top, it looks like we start touching at this arrow. But again, an arrow pointing down just means it's going forever and ever in that direction. So that means we're going to be starting at negative infinity. All right, and then once again, once we keep going up, it looks like we stop touching at this open circle right here, which is an open circle at 0, all right, with the parentheses. Again, there is a little gap if we keep going up from the bottom to the top, and we start touching our graph again at this closed circle right here. All right, so then there's a 1, and with that 1, I'm going to need a bracket because of the closed circle. And then again, just keep going up, and it looks like we stop touching our graph at this open circle, which is at 2. So 1 comma 2 with the parentheses. All right, so that represents all of our values from bottom to top. Let's try the exact same thing with this next one, right? Domain and range, right? And then I'm going to do the increasing, decreasing constant. All right, so domain and range, the domain, again, we're going to go from left to right. It looks like we start touching at this arrow, but again, arrow means forever and ever in that direction. So we're going to start at negative infinity. And if we keep going to the right, we're going to stop at this open circle, which looks like it's at negative 3. So it's going to be negative infinity, comma, negative 3 with a parentheses. I'm going to have a union, right, because we have a little gap right here, all right, and it looks like we have more of our graph at this value right here at negative 2, right, and it has a closed circle, so I'm going to put a bracket around it, negative 2, comma, and it looks like if we keep going in this direction, right, we stop touching at this open circle right here, which is at 1. So negative 2, comma 1 with the parentheses. All right, union, because I have another little bit right here, right? There is a gap, but we still aren't done with our function. So I'm going to start touching the function again at this value of 3. So it's going to be union with the parentheses at 3. And then again, you're going this way forever and ever. That means you're going towards infinity. All right. So this, in interval notation, represents all of your values from left to right. All right. Let's do the exact same thing with our range. All right, I'm going to go from the bottom to the top. And it looks like the first value we touch, right, if we keep going up, is at a y value of 1. Right? Now you see an open circle here, and a closed circle here. Now, how do you know what goes around that 1? Well, you're never going to want to just look at that open circle, right? If there is a value of 1 somewhere on your graph, you do need to include it. So this is actually going to have a bracket. Even though you see an open circle right here, right? If I picked this point, for example, right, it looks like right there is a valid y value, right? And it is defined at this value right here. So we are going to need a bracket around that 1, all right? Comma, and it looks like if we keep going up, there's 2 parts of our graph, right? There is a little gap right here, which if that was the only gap, then we would probably need a little union somewhere. But on this side of our graph, we are going up forever and ever, right? And that way this little gap is accounted for. And then once these two meet, right here, they're both going up forever and ever, right? So keep in mind with the y values, we are allowed to have 2 different outputs, right? This particular graph just has 2 different outputs for y. So we're going to go all the way up to infinity, and we're never going to stop touching the graph, right? It's going to stay going up forever and ever. So every value between 1 and infinity is our graph is going up and it's defined, right? So that's it for our domain and range. Let's try to find our intervals of increasing, decreasing, and constant, right? This is the part that sometimes gets some people. All right, so one thing to note with our increasing, decreasing, constant, right? So I'll write down increasing, decreasing, constant. You are looking only left to right. So let's see what that means, right? So I'm gonna go left to right, just like I would if I was going in my domain, right? I have an x value right here at -3, and from -3 to this point right here, it looks like we're going up, right? Hopefully you guys agree that if we're going from left to right, we are going up, right? Let me draw it. So we are going up, and up, right? And we keep going up, right? Where do we stop going up, right? We stop going up at this value of x at 0. So what we can do is we can say that we're increasing from -3 to 0, right? Even though you see a closed circle right here, right? Once again, like we said in the previous slide, you never want to include the open circle. You never want to include a closed circle in your increasing, decreasing, and constant, just because you can't be going up at a certain point, right? You can be going up between 2 points, but you can't really tell the behavior at the point where it ends, right? Once you finish, right? You're not really going up anymore. So we can't say that we're going up at 0, but we are going up between -3 and 0, right? Now look, where else on your graph are you going up, right? And it looks like we're still going up at 2, right? This x value of 2, and it looks like we are going up forever and ever, right? So we are going to write 2 comma infinity right here, right? Just because this represents we're still going up, right? Up, and up, right? So hopefully you guys see that. We're going up forever and ever. All right, so this is the interval of increasing, right? Decreasing looks like we're not decreasing anywhere, so I'm going to write none. And it looks like we're not flat anywhere, so I'm going to write none as well. All right, now the thing that gets people with the increasing, decreasing constant is they think, well, it's starting at 0, but it goes up to 2. So why did we say that it's -3 to 0? Because I don't want to know where it's going up from. I don't want to know that it's starting at 0 and going up to 2, that it's going up from 0 to 2. I want to know between -3 and between -3 and 0, this is where we are going up. I don't really care how high it goes, right? I just want to know where on the graph is it moving upwards, right? And that's between -3 and 0 and 2 and infinity, right? So hopefully that'll make more sense with these next examples, right? So let's look at this next one. I'm going to be increasing, all right, let me just write this down first. Increasing, decreasing, constant, all right? I'm going to be increasing, it looks like, from left to right, upwards, 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 from -infinity to -2, right? And let me explain how I got that, right? Because even though you see an arrow pointing downwards, right? Again, you're moving from left to right. So if I'm going this way, and this way, right? I'm still going to be moving on this little track up forever and ever, right? Up, right? So we are increasing from negative infinity to 2, right? Where else are we going up? Well, it looks like from this point right here, we are going up, right? Between 1 and 2. So I'm also going to be increasing from 1 comma 2, right? And we're not decreasing anywhere, and we're not constant anywhere. So I'm going to write DNE for does not exist, and DNE over here, right? DNE, or you can write none, right? Doesn't really matter, right? They mean the same thing, right? So nothing special really happened in those first two. Let me actually look at this one now, right? This one we're actually going to fill in the rest of the stuff, right? So increasing, decreasing, constant. All right. Now let's check, where are we increasing, right? Well, if I'm going from left to right, right? So left to right, it looks like I'm starting here in this part of our graph. Well, we're not going up, right? Even though you see an arrow pointing up, I'm looking at it from left to right. And if I pick, let's say, this point right here and this point right here, to go from here to here, I have to go down, right? So we are going down forever and ever until you get to this point right here at -3, right? So we're not going to be increasing at that interval. We're going to be decreasing. So we're actually going to decrease from negative infinity to -3. Right, let's just see what other behaviors we see at this graph, right? What happens between -2, between x is -2 and x is 1? Are we going up? Are we going down at this little bit right here? Well, we're not going up or down, right? We're staying completely flat, right? So where is that going to go, right? That from -2 to -1, to +1 is going to be constant, right? So I'm going to have my interval notation from -2 to 1 is we're constant, right? So we're not moving up or down. Again, put parentheses everywhere for this bit of information, right? You don't want brackets anywhere over here. All right, so this is where we're constant. We're not going up or down, right? And then what happens from 3 to infinity, right? It looks like we're going up, right? If I picked this point right here and this point right here, to get from this point to this point, I have to go up. So we are increasing. All right, and we're going to say that we're increasing from 3 to infinity. All right, so might be a little strange if you're not used to it, right? Some people I've learned can see this right away, right? I know it. I'm checking the time right now. I'm almost at 16 minutes of just this first 3 examples, but some people could probably see it in not even a minute or 2, right? But I know, just to account for everyone's experience, right? I know some people might not be able to see it as easily. That's as detailed as it can get, right? With this particular lesson, right? So the increasing, decreasing, constant stuff might be new and it might seem kind of strange, right? But you just need to learn how to think about it, how to analyze the graph. You're always going from left to right, and you're seeing, are you going up, down, or are you staying the same? All right. The next little bit of our lesson is going to be on even and odd functions. All right, so to determine if a function is even or odd, I would plug in a number and I would plug in the negative part of that number, right? And the information that this tells us is where it's symmetric, right? So an even function is going to be symmetric to the y-axis, right? What does that mean, right? Let's say I have a graph like this, right? This is x, this is y. Which means if I have something right here, I'm going to see the exact same thing opposite of this y-axis, right? So this is symmetric about the y-axis, all right? If it's an odd function, right, I'm going to do the same thing, right? Plug in a number, plug in the negative part of that number, and what information that's going to tell you is if it is origin symmetric, right? Origin symmetric just means, like, let's say I have something right here, then it's going to rotate 180 degrees, and it's going to be on the opposite side of my graph, right? So that's origin symmetric, all right? And x-axis symmetry happens when y is raised to an even power. A function cannot have x-axis symmetry, right? So we're not really going to worry about that. But x-axis symmetry on a graph, it would just look like, let's say I had something up here, it would mirror directly across over here, right? And a function cannot have that, right? Because then it would fail the vertical line test, all right? But you won't have to do anything more in this lesson than determine if a function is even or odd or neither, right? That's really all you're going to have to do. You're not going to have to graph anything using this information or solve anything more than that, right? And I'll show you how to answer those kinds of problems. All right, so let's determine if the function is even, odd, or neither. It's going to be the exact same test every time, right? What I would do is I would pick a number, like an easy number, something like 2, right? I would pick x equals 2, right? And then I would pick x equals -2, right? Pick the number and then pick its opposite. Let's evaluate f of 2. Let's see what that gets us. That's going to get us 2 to the third power minus 2, which is 8 minus 2, which is 6, right? So I got 6 over here, right? Keep that number in mind. And now let's do f of -2. This is going to get us -2 to the third power minus -2, which is going to get you a -8 plus 2, which is -6, all right? So I have a 6, and then I have a -6, right? If they are opposites, then it is an odd function. Odd function, right? Odd, opposite. Think odd, opposite. So I'm looking for opposite signs, right? So that's all the information that we really needed to find, right? As long as we get the exact same number, just one is opposite of the other, then it's an odd function, right? And that also means that it has origin symmetry. All right, so that means if I rotate this function 180 degrees, it's going to look exactly the same. All right, now let's try the exact same thing with the next one, right? I want to determine if this is even, odd, or neither. I'm just going to pick an easy number, right? So I'll just stick to 2, right? X equals 2, x equals -2. And now I'm just going to see what happens with 2, right? So I get f of 2 is 2 squared plus 1, which is 4 plus 1. So 5, right? We get 5 for 2. And then when I do f of -2, we get -2 squared plus 1, which is 4 plus 1, which is also 5. Right? If you get the exact same number, then this is even, right? So this is an even function. And even functions have x-axis symmetry. Right? And then we're going to learn, like maybe by the time you guys leave for Christmas break or as soon as you guys come back, you're going to learn what the graph of this particular function looks like. And it's actually going to look like that shape right here, right? Maybe some of you remember from Algebra 1. But what we're saying is that if I split it directly in half using the y-axis. Yeah, I wrote that wrong. Sorry, this should be y-axis symmetry. Let me get rid of that, right? This is y-axis symmetry. All right, sorry about that. All right, which means it's going to look exactly the same on this side as it does on this side. All right, so that's what the graph of our function looks like. All right, and now let's try the exact same thing with this one, right? 5 minus 3x, right? I'm going to pick f of 2, and I'm going to do f of -2, right? And this is going to get me 5 minus 3 times 2, which is 5 minus 6, which is -1. All right, so I'm looking for either a -1 or a +1 for this, just to determine if it's even or odd. This is going to get us a 5 minus 3 times -2, which is 5 plus 6, which is 11. So I got a -1 here and an 11 over here. If the numbers have absolutely nothing in common, meaning they're not the same number or they're not opposites of each other, then this would be neither. Right, so it's not even or odd. It's just a function, right? It doesn't have any symmetry. It's not even or odd, right? And that's really all we're asking of you guys in this particular lesson. All right. Very last bit of this lesson is we're going to find the zeros of a function. All we mean when we find the zeros of a function is we're going to set the function equal to 0 and solve. All right. So let's just say I had a function, right? I'll show you what this would look like on a graph. All right. Let's just say I had a function like that, right? And it looks like that. The zeros are going to be where it intersects the x-axis, right? So when I asked you to find the zeros, we're finding that point, and that point, right? We're finding where it crosses the x-axis, right? We won't have to graph these until much, much later, but for the sake of this lesson, you should be able to set a function equal to 0 and solve, right? So I'll show you what this means here. All right, so if I have f of x equals 2x squared minus 3x plus 1, if I want to find the zeros, all I have to do, set this equal to 0 and solve, right? So how would you solve this? You can do it a couple different ways. The easiest way is to check if you can factor. So 2 times 1 is 2. Factors of 2 that add to -3 are a -2 and a -1, right? So this does factor, and you would just factor normally. So you get x minus 2x minus 1 equals 0. There's a 2 in front, so let's divide by that 2. And we get an x minus 1. Slide that 2 up front, and we get a 2x minus 1 equals 0. And so I get x minus 1 equals 0. And 2x minus 1 equals 0. I can add 1 on both sides, and I get x equals 1 as one of my zeros. And then we can add 1 to both sides, and I get 2x equals 1. Divide by 2, and I get x equals 1/2 as my other zero. All right, so we should get 2 zeros in this case, right, because of our x squared. All right, that's really all we have to do, right? It's math that you guys have done a million times by this point, right? The only difference is the wording, right? It just says to find the zeros. All right, the only difference with this one is that now I have a fraction. But if you have a fraction, you don't even have to look at the bottom at all. All I'm going to do is I'm going to set the top equal to 0, right? Because let's say I gave you something like x over 2 equals 0. Well, when you go to multiply both sides by 2 to cancel out the denominator, 0 times anything is 0, so I get x equals 0 regardless. All right, so that's why anytime you have a fraction like this, all you have to do is set the top equal to 0. All right, so then we get 2x plus 5 equals 0. All right, let's subtract 5 on both sides. We get 2x equals -5, and then divide by 2. And we get x equals -5 over 2. And then that's the only zero of this function. Again, it's math that you guys have done before. It's just the wording is different. All right, and that concludes our lesson.